in pre-calculus class, I was really confused. I knew what limits in life meant, but what did limits in math mean? And when I finally understood what limits in math meant, I was like, that's awesome. Now I want to show you guys a real life example. We are going to use a dump truck and a tow truck. Let's say these two cars accidentally got in the same lane and they're about to collide. The space we're in right now is a limit. Now, how does this apply to the formal definition? Let's check it out. We are going to work with these two variables, delta and epsilon. Now, this is the symbol for delta that you would see in the normal formal definition. And in the graph, we're going to use A to symbolize delta. Epsilon, that's its symbol in the formal definition, and we're going to use that variable to symbolize it on the graph. I am going to draw the y-axis right now. And I'm going to draw the x-axis. Now, I'm going to draw a random graph because this is just an example to show you what a limit the formal definition applies to a graph. Here's my graph, and here is the limit we're trying to find. Now, this is, in the car example, this is the space before the two cars hit. So now, I'm going to draw A, delta, and L, epsilon. Now, these two have really special qualities. They can't be less than or equal to 0. If they are, then the limit isn't going to exist. And they have their own neighborhoods or parameters. Now, since this is a hypothetical example, we're not using any numbers, I can just draw random parameters or neighborhoods. So here's A's neighborhood and here's L's neighborhood. Now, A is actually more unique than L in one respect. It doesn't have to be in the middle. One side can be longer and one side can be shorter. However, L has to be in the middle and it has to be symmetrical. Now, I'm going to draw some lines just to show you that this is a limit. Now, I'm connecting their neighborhoods together, and as you see, this is a upside down L. It's rather big, but it's still an L. And this is what the formal definition means. In order for a limit to exist, it has to make a rather large L or a small l, depending. So since this is an L shape, that means the limit exists because it exists in between these parameters. It exists in A's neighborhood and L's neighborhood, so therefore the limit is here. Now you might be wondering, why does this matter? Why do I care about limits? And it matters because limits are the bridge to calculus. And once you get there, past the limit, you can understand a wide variety of what calculus has to offer. Adios!